Thank you all. How was the cake? Good? Happy birthday, Susa. It's great. So my name is Sveum. I'm the solution lead for EMEA for our storage and availability solutions. And I'm joined on stage by Carrero, our PM for HyperScale. And before I sort of dive into it, how many of you know Veritas and have used a Veritas product today or in the past? So that's actually quite a few of you, which is good, right? So Veritas is all about providing you with insight, availability, and protection for your data. The complete 360 data management solution. But it comes in the form of multiple products and capabilities. And it runs in multiple environments, both on-premise, in traditional infrastructure, virtual infrastructure, private cloud, as well as public cloud. And our capability here is really all about attaching to some of the topics that were talked about earlier, deriving forth the value of your data, turning that into information that is actionable, but ensuring that while you're doing that, you are reducing costs and accelerating velocity of operations. One of the key aspects of that is ensuring that the storage that we manage is maintained, resilient, and performant, and can be managed as efficiently as possible. And we have been in the software management or software-defined space for a very long time. This story actually started all the way back in 1991 or 92, when we didn't actually have shared storage. We actually had JBODs attached to Unix and later Linux device servers. And it's taken us on a journey that is now delivering awesome capability both in the public cloud and for the private cloud. And that's one of the key things that we want to make sure that we talk about today. Now, this project has gone under the radar for many of you because we've done so on purpose. But I've actually been here, this is my third year here, I think, Ruud. We've done this talk last year, but then the software wasn't released. So today, one of the key things that we want to do is we want to show you the capability that we're going to add. So what are the real big problems that we want to solve in an OpenStack environment? And you may think maybe they're not so big, maybe they're not that critical, but when we talk to large enterprises and customers who are running environments at scale, we recognize that these are huge challenges for them. How do I realize the economy of storage? How can I drive down my TCO without sacrificing performance, resiliency, and availability? How do I get the performance I need at the time I need it? In other words, how do I protect myself from the dynamics of the cloud where one workload can interfere with my I/O performance and pretty much ruin the performance that I need to deliver? Why am I focusing on performance here? The key thing is when things don't run at the speed that we want them to run, they're not available. And then finally, how do I provide data resiliency and data protection capability in a private cloud? The key here is to embed that as a storage service, something that is automated and end-user driven, but still enterprise-ready and centrally managed. This is exactly what HyperScale, our software-defined, scale-out, shared-nothing storage solution, has been built to provide. Providing you with resiliency and cost-aligned to the service capability that you want to deliver or need to deliver. Taking a step beyond what OpenStack on its own can deliver and allowing you to do more. Giving you predictable quality of service for storage performance. Understanding that at any given time, you know that this virtual machine or set of virtual machines is going to get this level of performance. Minimum and maximum. And allowing you to leverage that capability to protect yourself against noisy neighbors or noisy neighborhoods. And then finally, providing you with a management capability for the data, even in that shared nothing scale-out solution that is efficient and embedded in OpenStack. So how does it actually work? Well, we introduced this concept of a compute plane where we leverage local storage components inside of your compute nodes. Flash, spinning disk, PCI Express, doesn't matter. And then we introduce a new concept, the data plane, where we manage and maintain your resilient copies of data. It's a little bit more complicated than that, and we'll dig into the details in a bit. But in essence, this provides us with a capability to ensure that in that compute plane, we can deliver the right now I/O performance that any compute or virtual machine needs. We can optimize and provide predictability for an application or service. And then we can embed that capability and provide that capability as a storage service for the end user. So that the tenant who's spinning up a virtual machine, writing up a new service for their company, knows exactly how much performance they're going to get. We leverage commodity hardware to drive down the cost, and then we integrate it to ensure that we have a zero backup window capability or data movement capability. We dig a little bit deeper, solving this problem of managing storage in a hyper-converged environment where you're using local storage inside of your compute nodes. If you had to maintain resiliency for these storage components, you would immediately consume a lot of the storage resources available to you. By optimizing this efficiently, we have the capability to deliver I/O throughput optimization, predictable performance, and quality of service in that compute layer. And then embedding that functionality inside of Cinder and Nova. And then introducing the data plane in more detail where we provide you with higher density and data protection, and then SLAs for how you can provide redundant services. One of the key aspects here is that your data that you access is always local. So your virtual machine runs on a compute. It's always accessing primarily local storage. But I've talked enough theory.
Yeah.
Carlos, why don't you show us how this actually works?
Yeah, well, thank you, Peter. Very happy to be here. I was thinking about bringing my bike yesterday, too, when I went to the airport and got a message that the airport maybe was going to be closed. So I texted Ruth, said, well, maybe I have to drive the car or, yeah, do something. So very happy to be here. I'm very happy for being able to show you the product. As Peter mentioned, we got GA a few months ago. We just released last Monday the 1.1 version for HyperScale for OpenStack. And one of the key things, and also one of the key partners working with us for all this journey has been Fairbanks. Fairbanks, you can today use the sandbox where you can log in and you can test yourself and take a look to HyperScale. So that's what I want to do today here. So on the Fairbanks, you have the sandbox. I just logging into the system. And one of the key things for HyperScale for OpenStack is that it's really integrated with OpenStack. This is not just another backend storage solution providing a Cinder driver. We have been working very closely with Canonical. We've been working very closely with Red Hat. The message from these guys is this is a really cool engineering solution. You are attacking some of the challenges that you have today with OpenStack. So one of the things we do is integrate with Horizon. So we give the storage visibility for OpenStack into the APIs and into the management tools that you have. So here what you can see, we have the HyperScale tab, where you can see the overview, the hypervisors, the data nodes, so all the concepts that we have been talking in the architecture. You can have an understanding of what's your overall storage capacity and performance. You can go to the primary, the secondary, or you can go to a specific workload and understand what is the performance that you're having. The integration is not just here. If you go to your instances, you can take a look to the different instances running here, and you can deep down and go from one of these ones, see the different flavors that we're introducing. I will go into the flavors in a few seconds. But you can down to one of these instances and understand what's the configuration and what is the volumes. So here in the volume, we provide the visibility for things that we will be talking about, what is the resiliency of that volume, what's the minimum IOs per second, what's the maximum IOs per second. And also you have things like versions, so you can understand the point-in-time copies I've been talking about that are there, that you can use anytime for whatever you want. And also you have this version timeline, because you can take a snapshot anytime that you want. And of course, we will be integrating with NetBackup. One of the key things in this integration with OpenStack itself is extend the flavors properties. So when you install HyperScale, by default, you are going to get a bronze, a silver, and a gold flavor. But you can customize your flavors, because not all the workloads are the same. This is one of the key things for HyperScale. So what you do is that once you have the flavors, or you create your own flavors, you can go and say, edit, update metadata. And this is what I'm talking about, is that not all the SLAs are the same. You are going to be able to define what is your reflection factor at the data node, where you have your data management. How many copies do you want? Because sometimes 3 copies for everything doesn't work. One size fits all doesn't work many times. So you can define that here. You can define the maximum IOs per second and the minimum IOs per second. We have a breakout session, which I think is going to be amazing, from Rakesh, our manager from engineering, talking about credits and talking how the algorithm works and how we make sure that we can give you not just the maximum IOs per second, but guarantee a minimum performance. You have things like the priority. You have different flavors. Which one is going to have higher priority when you have resources contention? So we got all these things here that you can go and integrate with HyperScale. So let me go a little bit deeper into the architecture, how it works, and how we provide those 2 critical things, is the quality of service, the performance, and then the data management. Oh, yep. Thank you.
Thank you.
So is the other one?
Yeah. This is the demo factor, right?
Yep. Yep. Now it's black here.
No, now it's black. All right, fair enough.
I don't know what you
leave
did.
it. Yep.
Excellent.
Thank you.
Good. So one of the key things is that a quality of service for each of the flavors. So as you saw, you can define different flavors and define how much resources you can get, because solutions like Ceph with OpenStack works very well to share resources equally for everything. But not all the workloads are the same. So here you can define which one are more critical and you want to maintain a minimum IOs per second, and which ones you can go and avoid the noisy neighbor. So how you make sure, you have to click here.
Okay. Go for it.
Yeah. So you avoid the noisy neighbor and accelerate performance. So one of the key things is that at that compute plane, what we have is your first copy. It's the data you're using now. It's where you need IOs per second. It's where you need low latency. And today, all servers are coming with a lot of local storage. So HyperScale is going to get the benefit of that, to have the data locality. And that's the reason you're going to see some performance metrics at the end of the presentation. We make it completely different, because my writes, my reads are local most of the time. So how this works in action is that have that compute plane. That compute plane has some storage, what we call tier 0, tier 1. Can be ME card, SATA SSD, SSD, HDD, whatever your combination you want to choose, okay? And what we do is that we keep that first copy here in the compute plane. That's the copy you are using now. But that copy needs to be protected. But just to be clear, it's going to be protected according to how you define that in your flavors. You choose how you protect that. We do that what we call reflection. So what happens is that every write is going to be reflected, just that write, into another compute node. And you do that to protect that workload running in the compute. And you do that according to your flavors. What happens automatically is that every 15 minutes, we do what we call an episodic data sync. We copy those deltas every 15 minutes from the compute plane down to the data plane. And we generate a point-in-time copy. And the key thing here is that we separate the compute from the data plane. Going to the data plane, one of the key things is that by having that 15 minutes snapshot every time, that's your first line of recovery. As you will see now, or you saw in the what I
In the demo.
when I demoed, you had my 2 copies I had for my volumes. And I can use for ETL, I can use for recovery, I can attach that to another instance, whatever I want to do. Key thing is that this zero impact backup. There is no noisy neighbor. One of the big issues with a noisy neighbor is a backup itself. Because you have to go to the instance and read, and you know what? That instance is running with another instance that is doing something else. So that's the first noisy neighbor. Here, when you do a backup, or you have to read that instance, it's coming from the data plane. So my workloads keep running, doing affect the performance. And of course, as Peter mentioned, we are Veritas, being in data management for a very good number of years. We have leading products like Veritas Net Backup, where we integrate. And in one of the breakout sessions, we're going to show how we, when one-click, integrate with Net Backup, define policies, and show you how do you want to protect your workloads. Again, based on policies. So one of the key components is that compute plane, then the data plane. The data plane, and think about the economics of HyperScale, is that the data plane is cheaper and deeper storage. Your first copy is in the compute plane. That's the copy where you want to have performance. Your second or third copy that you define in your policies, if you need them, are going to be in the data plane. That is cheaper and deeper storage. So let me show you how this integrates with Net Backup. Now we have to change to the demo. It's going to be amazing,
Yeah,
right?
it's going to be amazing. Let's see if we can do
Wow.
that. So let's see here. No, it's going to be this one.
You make this thing like with the Mac, yeah? 3 fingers up.
I don't know. Can I?
He's a Windows guy.
I can't.
Oh, here we are. So one of the things, again, within HyperScale, you have what we define the backup export providers. So this is how we move data out of my OpenStack cloud. We have something like is external storage provider, or we register with a Net Backup, a Net Backup master server. This is one-click operation that we do once in the policies. And then what you got is the backup policies. Here, we have defined in the Net Backups some policies to protect our workloads. And then what you do is, yes, get the list from Net Backup, and you define for each of those policies what do you want to do. So you can go here and say, I want to see a flavor which is silver or Cassandra, whatever you have defined. And then run. And then what you do really is create a query and say, when this backup policy is coming to the data plane, you execute that query, you get the list of instances that needs to be protected, and that is going to be a snapshot and taken into Net Backup. So we're going to again talking about that and how we integrate, and you will show a demo about application consistent, how we use the QEMU driver to notify the application that the backup is happening. Okay, so pretty amazing. If you go also here, you're going to see all the tasks. So you get the visibility of the backups, restores that has been happening in your OpenStack environment. And just can go to the backups. When you go here, what's happening is that we query Net Backup master server, say what backups do you have? And then you have here the instance that has been protected and that are available. You just make one-click restore. And with that one-click restore, it's going to reach out to the Net Backup master server. It's going to get the data, copy to the data plane, and provide a new instance for you.
The key is that this is a functionality that the tenant would be performing.
Yep.
Yeah.
Yep.
So there are some significant sort of key differentiating factors here. Some key differentiating factors here. Solving these big challenges when it comes to storage management and automating that functionality and embedding it into OpenStack, but also extending the capability for an admin to provide the flavors of resiliency to their tenants, and then allowing those tenants to leverage that functionality automatically. enforcing data locality, which allows us to drive much higher IOPS, much lower latency, and better performance overall. And tying that back to service levels with quality of service capability as well as resiliency capability. Some instances don't need resiliency, but they do need performance. Some instances will need lots of resiliency, but maybe not so much performance. Some instances will need both, right? The reality is we need to have the capability to offer everything when it comes to providing this capability for a large enterprise. Taking that and then embedding that functionality when it comes to managing copies of data, whether it's for the developer or the person who's administrating a service to protect his own instance by right-clicking and snapshotting and efficiently storing that instance, or embedding it into a longer lifetime data lifecycle management capability that is then automated end-to-end without anybody having to go and script a whole bunch of different capabilities and managing those. Then reducing the numbers of copies that you have overall. And we wanted to share this. So this is a little view of a capability that we have validated internally, taking our stack and the Ceph stack and validating those two against each other for IOPS and latency using the exact same infrastructure. And you can see here that there's a significant benefit when it comes to driving higher IOPS and lower latency. But that's not all. How are we going to contribute to OpenStack and moving it forward?
So again, we keep evolving the product. We'll be at Sydney, being in the last OpenStack, doing a lot of contributions, going into triple O or speed director, UU terms. You can get UU terms to get the deployment. So really contributing with the community. We're bringing more cool stuff in the next version, like consistency group. We're able to get data snapshots that are distributed across your compute. So because the architecture, we are able to now talk to each of the computes, take a snapshot which is consistent for your whole application, and get that into the data plane. So a lot of new stuff which is coming.
Thank you, Carlos.
Thank you.
I know we went a little bit over time.
We get excited when talking about the
product. Yeah, that's good. We get to. Thank you for now. Yeah. I think questions from the audience you should do in the later sessions.
Yeah. Find us at the other sessions. Find us at the booth. We're more than happy to talk to you.
I saw something about reflection. My reflection was that it was quite long ago that I had the magic, because this is way, way beyond for me. But I'm not standard. So success selling this and traveling around the world, and success. And thank you for now.
Thank you very much. Thank you, guys.